Okay, sometimes these calculations are a little messy. Let's see how quickly and clearly I can do this. So f prime of x, by definition, is the limit as h goes to 0, the value of this function where x is replaced by x plus h, because there's a little deviation, minus the value of the function itself at x. What's this? X plus x? This is x plus 3. All over h. Now, what are the problems? When h goes to 0, this goes to 4 minus 2x. 4 minus 2x, the denominators are the same. We have x plus 3 minus x plus 3. So that's a 0 in the numerator and a 0 here in h. So really, we need in some way to combine, make our numerators interact to try and get rid of this 0 in the numerators. To bring these numerator terms together to hopefully get some interaction between them, we need a common denominator. So I'm going to restate f prime. F prime x is equal to limit h goes to 0. To create a common denominator, I'm going to want to multiply top and bottom by 4 minus 2x minus 2h. 4 minus 2x minus 2h. And here I'll want to so I'm multiplying by 1, but a very special form of 1. Here I'm going to multiply by 4 minus 2x. Top and bottom. And just to bring those terms together and see what happens, see if I can get some interaction and eliminate some of the zeros that occur. So, unfortunately, this is actually, I probably should have simplified it first. So I will here. I'm not quite taking those. I set up the multiplication there, and I'm restating it here. I don't want these videos to be too long, but there's no use in skipping too many steps and just being confused. It's easy enough to be confused anyway. All right, and this, of course, is all over h. We have that h lurking. Now, unfortunately, this might get out of hand, but hopefully only for 1 or 2 lines before cancellations kick in. There's 3 terms here, there's 2 terms here, so 6 terms are coming out. That's 4x minus second minus 4x squared plus 4h minus, 4x minus 2x squared. 4h minus 2xh plus 12 minus 6x minus, now this minus applies for that entire, this is multiplication, so that minus affects the whole back end. 4x minus 2x squared minus 2xh plus 12 minus 6x minus 6h. Everything all over, that's actually just the numerator. Now the denominator, you're thinking, wow, should we multiply this out or not? Let's see. H is going to go to 0. This is going to be 4 minus 2x, 4 minus 2x. I'm actually not that worried about the denominator right now. I'm going to leave it as it is. In fact, I'm so not worried about it, I'm just going to put ditto marks here. And just remember the whole thing is over h. Because remember, our problems are here in the numerator. It's the numerator that the zeros are appearing in. So this denominator, I'm leaving. I'm not even going to talk about it unless an issue comes up. So a big, long, messy line, but we have it lined up, and we have a negative 4x here, and we have a positive 4x there. We have a negative 2x squared, and we have a positive 2x squared. We have a 4h here. Well, we just have some h's there. Let's leave that. I don't see a direct cancellation. We have a negative 2xh. We have a negative 2xh. We have a plus 12. We have a minus 12. We have a minus 6x. We have a minus 6x. Now, okay, I'm just going to rewrite it. Again, limit h goes to 0. Our numerator is 4h. Move along. I don't see anything left except I see a negative 6h. I think that's plus 6h all over my denominator, which I'm not even paying attention to. Limit h goes to 0, and I'm not paying attention to it because I don't think it explodes in any way when h goes to 0. It's not the source of my problems. Indeed, my problems are disappearing rapidly because this h cancels with, there's 10 h's up here, both of those. Limit h goes to 0, I have 10 over my denominators, which I'm going to bother writing now because that's all that's left. Okay, now I can actually take this limit. 10 remains. 4 minus 2x. This is 0. 4 minus 2x. This is 4 minus 2x squared. That is the derivative by definition. And if I want, I should probably take this and go in Wolfram alpha. Derivative, and then x plus 3, 4 minus 2x, and just check my answer. I'm going to do that now, and if I find a mistake, I'll have to come back and correct this video.